Hello, my name is Andy Newen, and today I will be doing some freestyle programming. Today's topic will be about unit testing. So I'll go over some basic concepts as well as some more advanced ways of doing unit testing. This is my first time doing something in this freestyle video format, so if you have any feedback, definitely let me know. But let's get started. To start off, I'm going to introduce the topics starting from more of a beginner standpoint, and then we'll ramp up as the content goes along throughout this video. So let me set a baseline of kind of the tools and technologies we'll start with, and then we'll just go on from there, solving a basic problem and unit testing the different components and services that go along with it. So today's tools we'll be using, we will be using IntelliJ Community Edition. It is an open source IDE made by IntelliJ. So let me just search that up for you real quick. This video can be followed with using any IDE. You can use VS Code, you can use Eclipse, you can use NetBeans, but I'm using IntelliJ Community Edition because it's the best open source IDE that I've found so far. VS Code is up there, but we'll use IntelliJ for today. So if you don't have it, you can download it here on this website. Another tool we'll be using is DrawIO. DrawIO is a diagramming tool. I will be using it to explain the different concepts and services and the kind of the problem we'll try to solve today from like a higher level perspective, less into the code and more of a picture-esque standpoint. If to get DrawIO, and I would recommend the desktop edition. This is also an open source program. Just search up DrawIO desktop, and the download will be on GitHub. You can download it by clicking on the releases link over here. So once you go to this page, just download it using whatever platform that you're running your computer on, whether it be Windows or Mac or Linux. So download that tool, and you'll be able to open up the diagrams that I'll be sharing as part of the resources of this video. And then the third tool we'll be using, I would consider it a combination. We're using Git as version control software. If you don't have experience with Git, I'll go over some of the basics, but I won't go explain it too in depth. But it's definitely right now the most used version control sort of way of managing your code. So make sure you download Git, and I will be hosting my repository on GitHub. So once you download Git and you clone my project through GitHub, you'll be able to see all the changes that I make today in this video. So make sure you get Git, and then we will be using GitHub as our platform for where we're putting the Git repositories. So I think we are ready to start. Let me open up a version of DrawIO. And today's problem we're going to solve is not too difficult. And I want to start with a sort of an easy problem so that we focus on less of the difficulty of solving problems and more of solving the idea of making software in a production fashion. So instead of tackling the idea of a hard problem, we'll be tackling the idea of structuring and making a well-tested software. So today's problem, and let me see if I can make this a little bit bigger. I'll zoom in. It's going to be really simple. So we will be making a program that takes an input X and outputs a variable Y. And the formula that we are going to start with for this program is going to be Y equals 5 plus X times X minus 5. And that is the program that we are going to make today. I will also expand this program a little bit more out so that we can see how we can evolve our software over time and create unit tests in a way where it's easy to add and adjust features as the project gets older and older. So first thing we want to do is create a new project in GitHub, a new repository. Let me create unit test, soft unit tests, video. We'll name this today's date. Freestyle tutorial on creating unit tests. Somebody's playing Skyrim, so I will exit out of Steam. All right. Let's see. No readme, no gitignore, no. We'll change the license to the MIT license. Let me create this repository. All right, our repository has been created. So what I will do now is we will use IntelliJ to create the actual project, and then we'll be pushing our changes up into this repository. So let me open up IntelliJ Community Edition, create new project. We want a Maven project. We use Maven and not just Java because we can install the dependencies we need to do unit testing. So I'll click here. We'll call it, well, the group ID is just my domain name. So andyln.com. And then the artifact ID will be unit test video. And we will create this project. All right, that opened up. So let's import any changes for our Maven project. And the first thing we want to do is upload our project to GitHub so that we can know that we can apply our changes and do everything we need to do to set this up. So let me make sure that we can share the project onto GitHub. it turns out we can create a project over here. So I'm going to delete that other repository that I have on GitHub and just do it that way for simplicity's sake. Let me take that description out. Let me delete this project. This one. And I do understand the consequences, so I will delete that repository. All right, now that we've gone past that, let's bring that repository back up on there using IntelliJ. The name is already there, so I'm guessing it saw that the name was the same as the one that I just deleted. So let's change this up to be video tutorial, maybe? Yeah. Yep, let's do that. Let's add all of this onto GitHub. Let's check the GitHub website to make sure that that got uploaded successfully. Unit test video tutorial. All right, that is up there. Some more basic setup that I want to do is I should be able to add a README automatically. So I will just do that. What else do I want to do? I want to add that MIT license on there so you can use the code in your own projects without having to worry about any copyright. So let's see if there's an automatic way. I'm not sure, but let's just search up for the MIT license and let me add that real quick for you guys. You know what? I have an MIT license on most of my projects. So if I download one of my projects, I will be able to see how this license is actually created. Yeah, let me copy this one. Create a new file. Right click, new file. Yep, just a text file. Add that in there. Year is 2020. Here we go. IntelliJ Community Edition autosaves, so we're good on there. And let's make our first commit. Add a license. Let's unclick the other stuff because there's one more thing I want to do before we start solving the problem. Let me push that out. Need to pull down the changes from the README that we added to the GitHub tool. So we had to do a pull first, and then we were able to do our push out. And the other thing that I wanted to do, and apologies for taking a second to get everything set up, I just wanted to show everything that's needed to get a project up and running from scratch when doing this freestyle video. That will help not only people more advanced and experienced when you know, experienced and advanced, just as. Let me take a second to restate that. I wanted to start the project from scratch so that not only do people with experience and, you know, some years working in software development to gain value from this video, but also the people that may be newer in software development and their careers. And even the people with no experience whatsoever. So that's what I wanted to say. So thank you for letting me take the time to say that. Let's go into one of my previous Java projects so we can get the file that's called a gitignore. A gitignore file allows you to ignore certain files from being uploaded to Git. So there's like maybe some specific configuration files for your specific IDE that you may not need or want to share out to other people, and for their when they download the project. This prevents overriding some settings that may come up during a clone of that project. So let's say I upload my project, right, and then somebody wants to clone the project, but I don't want my specific IDE settings to conflict with the settings that they may have on their local computer. So that is why we have a gitignore. And there's some other benefits too, but we'll not cover those. I am just gonna generate a gitignore file and bring it into the project. This is a useful website for generating gitignores. We want IntelliJ, we want Java, Maven stuff. Yeah, I think that's it. So copy all that stuff. And then we will add the gitignore file. All right. Let's commit this all out, and we should be ready to get up and running. Add gitignore. Commit and push. Yes. All right. All right, so that took a little bit to get the project set up, but now we should be ready to get back into working on the code that we want to implement. So give me a second. All right, opening up the program, we want to create a program that does the following. It takes an input X, outputs a variable Y, and here is the formula that we are going to be starting with. So let's begin. I will create a class that will be the entry point into our application. let's just call that application for now. Let's add that to the Git. And this is the entry point. So if I hold Alt and press Enter, that's not actually the thing I want, but we'll see some stuff here that may be useful for creating unit tests. But I want the entry point of the application. So in all Java applications, you have a public static void main string array of arguments. And that is just the boilerplate code really needed to start a Java application. So let's solve that problem that we wanted to solve. We'll take an int x and an int y. And we'll do some print lines, I guess. We'll do my input x is equals whatever x is. Out.println. My output y is equal to whatever y is. And let's print this out. Let's run this and see what we get. I'm missing a plus. Let's run it again. All right, so it is yelling at us because we never specified what x and y is. So let's say x is equal to, I don't know, 10. And y is equal to 5 plus x times x. Oops. Accidentally hit something there. 5 plus x times x minus x. All right. X is equal to 10 and y is equal to 140. So we can double check that real quick. So 5 plus 10 is equal to 15. 15 times 10 is 150. 150 minus 10 is 140. So from just manually parsing our input, we can see that this behavior is what we expected. But let's say the program is not as simple. Let's say there's some conditions. Let's say, maybe the formula isn't as easy as something like this. We would want some way to test and make sure that our program works as expected, not only right now, but when people are adding new stuff and features in the future, we would want to make sure that the program also works as expected in that case as well. So what we're going to be doing right now is we'll abstract some of the logic here out into a separate class where we can test and verify the stuff that we're doing here will work here and in the future in a more composable fashion. So what I'm going to do is, first things first, I'll commit the file just because we have something working and we want to make sure that if we break something, we can go back to it. So let me solve the initial equation as our message. And we'll push that out. Next thing, oh, apologies, I just hit my mic. Next thing I am going to do is I'll create, we'll call it like a calculator class, I guess. A calculator, not here. We'll toss it into our static void main. So we'll have some sort of calculator, and we'll call it calculator. It doesn't exist yet, but we know we're gonna make it. So let's ignore that red error for now, and we can be like, we can comment this line out. We'll reference it, but we're adding new stuff. So we could, instead of doing int y equals 5 plus x times x minus x, we could be like y calculator. And we can be like, there might be a method on here that's like, create y for equation that's x. That method doesn't make sense. Let me think of a better name for it. Maybe calculate y is a better name for this. Given x. Or we could just be like calculate y. All right, so we have a bunch of red. And that's scary. That means you can't run your program, right? I tried to run this and it's gonna be like, can't find symbol and nothing works. So what we want to do is we'll use IntelliJ, and we'll hold Alt and press that Enter. And IntelliJ is pretty smart. It will give us some options on different things we can do. So we can create a new class called Calculator, and it wants a package. So I'll toss this. I'll just hit OK, just the default. Just put it wherever you think it's gonna most fit. And it put it on the same level as this application, as we see right here. So we don't have a red here anymore, but it's never assigned. So we got to make sure that we initialize this properly. So we'll create our calculator. And now it's going to be like, it can't resolve method calculate y because calculate y does not exist. So the next thing we'll want to do here is to create that method within our calculator class. So we'll go here, and we can be like, calculate y given an input x. And what we want calculator to return is an integer. So we'll expose calculate y as a public interface, and then we'll make it an int. And so there's no red here anymore. Let me run the program one more time. It's missing. Sorry, got a little bit too close on my mic there, and it just fell onto my keyboard. So give me a second to reset my my setup here. All right. So I hope that still is working. So we got calculate y here now. It's not working because this method is supposed to return something. And the thing we want to return is this equation right here. So let me take this out. Well, we'll put it right there, and we can be like return. Let me just make an int y which equals that, and we can return y. Let's run this. And everything is still working as expected. We see that 140 is still there. We see that the 10 is still there. Everything looks good. So let me first things first, commit this out. Add all the stuff. Create our calculator for our equation. And let me push that out as well. Push that. Next thing is, let's do a little bit of cleanup before we continue. We can take out this comment that is no longer needed there. And we notice that there's this little light bulb on the side. What is that telling us? Clarifying parentheses. All right. It wants us to do more parentheses, I guess, which is fine. And here's another suggestion that it's saying. Y is redundant. So it's like you declare this variable y, but you're really just returning this output immediately. So what we can do here is, instead of declaring y equals this, we can just return it directly instead of making the variable here. We do that. And that looks good. So let me commit this out. Code cleanup. All right. Or cleanup code is also another one we can do. Let me push that out. All right. So this is where things get interesting. We'll be starting the unit testing of this calculator class. Let's say you have your application and you make this method calculate y, and you can test it manually every single time. There's no problem with that. But as your program grows more and more, and you're adding new features, you're gonna hit a point where it's like it takes longer to do manual tests than writing the new code and the new features that will, make you money, create a better product, and all that nice stuff on why we do programming in the first place. So to avoid that situation, we can create a test. And one of the tests that is kind of the most one of the most popular and the most used usually in a project is the unit test. So I'll create a unit test right now, and then we can go more in depth on what really makes a unit test and cover all the stuff that you need to do to get all that stuff working. So one way to create unit tests quickly in IntelliJ is that alt-enter stuff that I was doing before. Click on that class and you can do create test. The default is Groovy JUnit. I prefer to use JUnit 5. It's just my preferred way of it's my preferred testing library, so that's all there really is to it. But the same concepts will apply whether you're making a Java unit test in other testing libraries, or if you're creating tests in other languages. The concepts still apply no matter what language or library you use. So I'll hit fix so we can get that JUnit library into the project. I'm guessing it worked. It didn't update here, but I'm guessing it actually worked. So we'll hit OK here, and we'll add that to Git. So clicking that fix button, all it really did was add this JUnit dependency to Maven, and then it imported that dependency. And that's why we use Maven, because it allows us to use libraries that give us a lot of benefit and prevent us from just copying, pasting code from all sorts of places and manually downloading libraries. Maven allows you to use libraries in automated fashion. But we'll cover that more as we get more and more libraries into here, because there's some useful libraries that you can use with unit testing to make your lives easier. So we have our application, and our tests got created in our test folder. So the first thing we want to do is to construct our object. So if we have a calculator test, we probably want a calculator in there, right? And then we could have some sort of just like a setup class or a setup method. I think there's a way of auto-generating this too with IntelliJ. Let me generate the setup method. Yeah, we'll add that. Ooh, that is not what I wanted. That is not what I wanted. I'll copy this code, but this is not what I wanted. I didn't want to make a test for my test. I just wanted to get the method there. So we have our calculator, and we have our setup. And before each of our tests, we want to make sure that we have a clean calculator. We don't want to reuse our resources in between the tests. We want to make sure that we're in a clean state. And this can be private, so we can make this private for that. Let's do our first test. In JUnit 5, you add this add test annotation. And our tests are going to be public void. And we're going to be like given an input of 5 when our calculator calculates. Then we expect our output to be 140. Write your tests in a readable format. It doesn't have to be in this specific hyphen delimited, not hyphen, underscore delimited fashion. It doesn't have to be this verbose, but make sure that you're writing your tests in a way that if somebody else was to look in your application or project, that they would be able to go in and see what's actually happening here. So doesn't have to be like this, but just do your best to make it as clarifying as possible. So let's create a unit test in kind of the production way of doing it. Production being not only are you making tests for, you know, fun projects, but, you know, tests that in projects that, you know, you might be working on like a $20,000 project, or like a $500,000 project, or basically a project that makes a lot of money, right? Let's create the tests in a way where we're confident that these tests will be suitable for that type of project. Obviously, this project that we have right here is not a $500,000 project, but I just wanted to give those examples out there. So tests are usually made in this given, when, then format. Now, it might be complicated just starting this from a beginner standpoint, but kind of how like a given, when, then works is like, given is kind of like, you know, like it's kind of like your setup, right? You're setting up everything that you need for your test. Your when is like, run the thing that you want to test. And then is the like, you're asserting what you want to be true is actually true. So I'll explain that last one a little bit more detail, but if we start from this top to bottom approach, we can see that this is going to be pretty simple. So given our input 5, so let's make our input equal 5. We can call it input here. Something else that we've called in before is x, so we can make this x right here. When, so calculator, calculate y of 5. All right, so we did our thing, and now we have to assert something. We needed to make our then. We need to basically make our check. So what are we checking here? We're checking that the value returned from calculate y, in this case, is 140. So let me make sure that I save my value somewhere so that I can actually check to make sure that it's the value that we say it is. So we store it, and then we do not return. We want to assert equal that our expected value equals our actual value. We can be like 140 is equal to y. We expect y to be 140, but we don't know yet. We're just checking to make sure that it works. I put 140 here, but I can even take it a step further and be like, and expected equals 140, and just be like, assert equals our expected equals y. Annotations aren't allowed here. Why is that the case? Because I forgot to put parentheses around my method. That is why that didn't work. Forgot a semicolon. All right. So it is yelling at us. It's like, hey, wait a second. You said this was going to be 140, but this was actually 45. What did I do wrong here? I'll give you a second to try to figure out what happened here. All right, now that second is over, if we remember when we did our manual test, our input wasn't 5. What it actually was 10. So in this case, the test failed because obviously if it's 5, it's not going to be the same result as it is if it was 10. So let's set this to 10 and see what happens. Change that to 10 and it's still erroring out. What is going on here? So when you're testing or writing any sort of program, make sure that, you know, take it line by line and see what's going on, see what's going on, and what problems we're expecting. So expected equals 140, x is equal to 10, and then we go to here and it's like in y calculator calculate y of 5. Wait a second, that's not supposed to be a hard-coded 5. What we were supposed to put in here is x. We put in x over here, and we can do that. And our test passes. So now, instead of having to manually run this application every single time with this 10, we can have our tests do our work for us. Now this is useful if we want to test different inputs. Let me commit this out because we have some working code and we want to make sure that we have a placeholder in case anything goes wrong. So we'll create first test for calculator. And we'll make sure we commit the arpom XML, which has our JUnit dependencies. At this point, since we know we have working code, I think it would be good a time to do a little bit more fixing of stuff. In IntelliJ specifically, if you see this little yellow bar right here, that means there's a warning, or there's something that can be changed to make it kind of like better code, some automated checking of your code to see if anything can be improved. It's complaining that this should be package private. I'll ignore that for now. That's not too big of a deal. That is that. This one's probably also yelling that it can be package private. Yeah, I'm just gonna ignore that package private stuff. It's not too big of a deal. So we can let's continue making more tests. Let's say that we don't have 10. Let's say we're doing 5 as we were doing before. It can be like giving it an input of 5. When the calculator calculates, then we expect the outcome to be 45. 45, 5. Run our tests. All right. That is working as expected. Let's add more tests. What else can we do? We've been doing some really like basic numbers, right? Look, they're not anything too fancy, but we can try some more fancy stuff. Let's throw in a -5 in here. And so if I do this calculation, well, let's do 10. 10's a little bit more fancy. So if we have 5 plus -10, we have -5. -5 times -10 is 50. 50 minus -10 is 60. So we expect our output to be 60. We'll do that. We will run our stuff. See what happens. And the problem here is I never changed x, so we will change that. And we never changed our expected either. This should be 60. Oops, that's the wrong one. Hold up. That is that. That is correct. This one was supposed to be negative 10. That is working as expected. We run all our stuff. All right, we are good there. Let me commit this out. This is create more tests for calculator. Calculate. We will git commit and push that. All right, what now? There's a feature that I want to show off. We can run our tests with code coverage. We can see how much of our code is actually tested. So I will do that. Application is 0. We never made it for that class. And I think for this video I'm not going to create tests for application. Use your own experience and knowledge to create tests for your application class in your projects. But today I kind of want to get more into the meat of things with the functionality in the calculator here. But there's nothing stopping you from creating unit tests for your application if you so desire. Let's make this even more fancy. I want to impose an arbitrary restriction on here. And it's like, you can say it's like, hey, this isn't real life. Like, why are you making this restriction? So give me a second to save this. I want to save the diagram into our repository as well. So let me open up an Explorer. Get that. Give me this file path. Save as. Get into the right path. And we can be like video diagram. We'll save that. Arbitrary restriction. In this case, arbitrary meaning just random, really. Calculator cannot use plus, minus, and multiplication directly. Must use other classes. So you might be like, why am I making you do this? Even though it's plus and minus and multiplication is really simple. Well, let's say you aren't making something as simple as a calculator with plus, minus, and multiplication. I want to show a way where we can make sure that our code works, even if you're working on something a little bit more complicated. Let's say you have something that's like, make this image black and white, or you have something is like, tell me what the lottery numbers were in 1996, something like that. Or maybe you're just using something that's like, turn turn this English-based document into a Spanish document. Just some more advanced stuff. This is a way, like interviewers can impose these restrictions on you, so they can test to see how you solve problems. Given in a like a safe scenario and a scenario where you're not working on necessarily a difficult problem, but that you know the strategies to solve difficult problems as time comes, and as you get asked those sort of questions in the future. This is a way of training you to make sure you can solve those types of problems. So, that being said, let's do this. How do we do this without directly using it? Well, we can create even more classes that that have the methodology hidden behind a way in an interface that we can use. So if I were to imagine this right, we could have something that's like an addition service, maybe. And an addition service can maybe add two numbers together, like let's say our 5 plus our x. And we can store that in y. And then after that, we could be like y is equal to a multiplication service. And we can multiply y and x. Not x. We can do, y and x. Yeah. And then we could have something that's like y is equal to our subtraction service. And that can be like y and x again. And let me flip these around. No, let me keep them like there. And so how this looks, if we comment some of this stuff out, this could be like y is equal to 5 plus x at this point. And then we could be like y is equal to 5 plus x times x. And then after that, it could be like y is equal to 5 plus x times x minus x, in that sort of fashion. And then we can just return y at the end. It is yelling at us for several reasons here, obviously. First off, we never declared y. We should probably say that, maybe y starts off as x to start off with. Let me take this out here. And maybe we'll put y in here for consistency reasons. So we could start off here as y is equal to x. So we do y equals x, y equals 5 plus x, then we get the multiplication, and then we get the subtraction here. What's going on here? Why is it yelling at us? Well, our service, these services don't exist currently. So what we want to do is we want to make sure that we have an opportunity to create these services so we can use them. We'll create them. We'll create them in here for now, but as you'll see, we will want to make sure that the code works as intended, and we will be moving some code around. So get ready for that. It'd be like our addition service equals new addition service. Our multiplication service equals multiplication service. And our subtraction service equals new subtraction service. All right. Why is it yelling at us now? Well, these things don't exist. So let's create these things. Create that one. We'll create that one. And we'll create this one. Go back into our calculator, and they're like, these methods don't exist. It'd be like, create that. Create that. And create that. Well, I messed up here because these are supposed to be lowercase. So let me make sure these are lowercase, because that is what we named the variable. Let's get rid of these statics. We could, in this scenario, we could use statics, but in the code that you're actually probably going to be making, these probably are not going to be static. So for example's sake, we will delete them. Let me just change these into XY for consistency on all of these. Oops, cancel that. Didn't mean to click on that. Apologies. All right. We have code that's not red here. But this is not working. So it's going to be like, you don't have subtract here. Let me subtract in the subtract method. Let me multiply in the multiply method. And let me add. We need to add in our addition method, or our add method. So y is its x should not be assigned to y. You know what? It's complaining about that, but I will just ignore that for now. Keep it like this, just so that the code is easier to read for somebody looking into this. You don't always have to take suggestions, but it's usually a good idea. All right, everything now works, even though we have our arbitrary restrictions in there. Let me run it with code coverage to see how much coverage we have here. It is covering all of the addition service, all the calculator, the multiplication, the subtraction. Everything seems to be tested here, right? So you might be going, "Hooray! We've solved the problem." But there's a problem here that is kind of subtle. What we've done in this case is tightly couple our calculator with our addition service, our multiplication service, our subtraction service. In this case, our test relies on the fact that calculator and addition and multiplication and subtraction are all tied together. But I want to test calculator independently. And again, in this example, it's super simple. It doesn't really matter that these are tightly coupled. But when you're working in real production software, you will see that you'll need to rely on other classes and other services where you don't want to have the mental load of knowing how all these other services work and how they apply, right? So let's say instead of like an addition service, you had a service that was like turn a colored picture into a black and white picture. You don't want to test all the little things where it's like this pixel turn gray at this certain shade and this pixel turn gray at this shade and this pixel turn that color. No, you don't want to have that mental load of knowing how it actually works. What you want is something like, I have a service that turns a picture black and white. I'll assume that this service will give me this picture, where this picture being like some sort of black and white picture that you created for your test. That way, you can test your black and white stuff independently, where you have tests for your black and white service that does those little independent pixel checking stuff, and then you could have whatever you're doing here with that black and white picture just working on that output and whatever that is doing. So in other words, you don't need to create two tests that do the same thing. You don't have to create a pixel checking thing in one service and the same pixel checking thing in the other service. You only create that test in the service that actually cares about the white and black picture, and then the other one, then you just work with what output you wanted from there in the first place. So I've gone on a little tangent explaining that stuff, but let me implement this out to show you all how this will work for something like our calculator. First off, our code's working. Let's make sure we commit this out, push it out there as well. Implement arbitrary rule. Arbitrary. And we will commit and push this out. All right. So how do we do it? How do we make sure that we don't tightly couple our stuff together? Well, first things first. instead of making our addition, multiplication service, and subtraction service within the method itself, we can actually pass in addition service and multiplication service and blah blah blah, etc., as parameters to our function. Now this might bloat up our function in this case, so I'm gonna not put it there. What I'm gonna do is create a constructor for our calculator, and we'll call it that, and we'll be addition service, multiplication Control Z, and our subtraction service. And we can be like this calculator's addition service is going to equal addition service, where addition service is what we create up here. We can also do it for a multiplication service. And we can also do it for a subtraction service. So that is equal to that. That is equal to that. And that is equal to that. So we'll do addition service. Our addition service for this class is going to be like that. We'll make it private, so it's not accessible outside that class. Our multiplication service comes in here, and our subtraction service comes in here. So let's run stuff. Let's see what happens. First things first, in our main, we've updated our constructor, so we need to make sure that everything is created out here as well. Let's set up that. And our multiplication service. And our subtraction service. And we will pass it into the constructor. Let's run our stuff again. All right, now it's like our tests aren't working now. Same thing here. Let me save all of our time and copy and paste. Actually, we'll take that out eventually, but copy and paste that. In our main application class, we had something like that. All right. And now everything is going haywire. What happened? Why is this not working? It's just because we accidentally recreated it here. So let's make sure that we're using the right one. And we'll say this.calculator and make sure it doesn't error like that out in the future. All right, everything works. Everything is good, and we've separated out the services. One additional thing to add is this should not be here anymore since we've created it in our constructor. And for confidence sake, we can run it again. All right, everything is working. calculators like that. Run it with coverage. Yeah, everything is still working. Still tightly coupled. Why? What's going on? What is going on here? Well, what we did here is an integration test. We're still using the addition service, the multiplication service, the subtraction service. We're just passing it in through something called Dependency Injection now. But what we really want to see in these unit tests is we've only made our tests for calculator. We shouldn't really be seeing any numbers for addition service or multiplication service or subtraction service because we did not make unit tests for those. We've only made integration tests. And integration tests are also fine. Maybe your team wants to work in this sort of fashion where you want to forego some unit tests and do integration tests. What you'll find with integration tests, as the more and the more you make them, you will see your program, and not just your program. We'll see your test. So ignore that I said program there. Well, you'll see that when you run your tests, they'll take longer and longer and longer because you're making real services and you're integrating them with whatever method you're testing. And so it's not so here, but there may be some services that, you might have a service that's like, wait 15 minutes and then do this. Do you really want to use that service in your test? The real one? Because you'll have to wait 15 minutes every single time you run a single test for that service. Imagine if you had, I don't know, 10 tests for that. Still, maybe 15. May all the tests run at the same time. Maybe you're only waiting 15 minutes, but maybe you're waiting 30 minutes or 45 minutes. You're waiting an hour to run your tests. There's only so much time that you have during a work day to get stuff done. Time is money after all. So we need to solve this problem. Let's say it takes forever for one of these services to run. How do we use the tests in a way so that not only are we only testing the stuff that we've wanted to test, but to make sure that we're testing at a unit level, testing only calculator because that's what we said we wanted to test. Here is the stuff where if you've heard the term mocking, this would be the perfect time to use it. So the general concept is, instead of using a real addition service and a real multiplication service and a real subtraction service, we can put in placeholders in our tests, which we can say it's like adding any two numbers. This will always return this output. This will allow us to avoid the situations where it's like, wait 20 minutes and then return this. You can, in your mock, you can just be like, return this immediately and not have to wait those 20 minutes. So let me start implementing some of this stuff, and maybe it'll be more clear after that. So in here, we used a real addition service and a real multiplication service and a real subtraction service. What I want to do here is mock. And the perfect tool for Java for when you want to do a mock is Mockito. And in different languages, there's different ways of making mocks and stuff like that, but we'll be using Mockito today. And I want to use Maven, so let's get all of that stuff in there. I don't want the beta. Not feeling that risky. We will, if you didn't see what I did there, I just copy and pasted this, and it's a dependency, so in your POM XML, just make sure you insert it in the right place. We'll toss it at the bottom for now. All right, we got Mockito in here. So instead of a real addition service, what we can do here is I'll comment these lines out so you can see them as we change them off. And to do that fancy comment that I just did there, you can hit Control/ or Command/ or whatever shortcut it is to make those comments. But let me copy this, and we can be like, I don't want a real addition service. I want a mock of an addition service. It's gonna yell at you, but all you have to do is alt enter and import that method from Mockito. Same thing for the multiplication service. Apologies, I just hit my mic yet again. And then you got your subtraction service. Let's see what happens when we run this code. All right, perfect. Nothing works. And you're going to be like, Andy, you said perfect. Why does this not work? Well, it is expected that this doesn't work, because when we mocked out the stuff, we never specified the behavior of those mocks. So often you'll see null pointer exceptions, and it's going to be like, you're calling something on a null method. This doesn't work. What's going on? We're using ints here, which are primitive values, so it's a little bit different here, but the general concept is usually the same. So we'll see actual B0 in all of these cases. Let us start from our top test and fix it. And as we go along, we can change the test stuff and see how things work in the way that we want them to work. So this might seem counterintuitive, but in Mockito, to set up your mocks, you input the when statement. So I see a lot of new programmers get confused because the when is not in the given and not within the when area. But as you gain more experience, you just kind of know that's in the given. But if you just realize that when in this case doesn't mean when executing, this just means when as in setup, you'll get used to it over time. So when our addition service dot, well, first I need to import this from Mockito. So when our addition service dot add, and we'll just say any integer, any int. Because in this case, we're these mocks, we know how they're gonna work. We know that in this case, one thing before I continue is we need to refactor something up here. Our mocks are not available they're not exposed for us to use. We need to make sure that we bring it up into the class level and declare the variables up here so that we can use them and set them up in our tests. So we'll do that. We'll do that. And we'll do that. All right. So in this case, we can then return what do we expect here? We expect it to be 15. When our multiplication service does its thing. Then we expect that to be, let's see, 15 times 10 is 150. And then we subtract here. That's 140. So it's when two things get added together in this mock, return 15. When any two things get multiplied, then return 150. And then when it's all of that stuff here, then it's returning 140. Let me run this to make sure that it runs successfully. We got a null pointer exception. All right, what happened here? When we add two things, add, then return 15. Addition service, subtraction service. Well, it needs subtraction service here. I want to make sure we declare it when we subtract. I think this will still fail, but let me just make sure. All right, what is going on here? Let's expand this out. When add, what is going on here? This is actually confusing me. And this is why this is a freestyle thing, because I don't have a script in front of me. I'm just going along as it comes along. So there's an any int here, so that's any int null pointer exception. What is going on? Let us figure out the bug. Maybe it's this. No, I don't think it is. We're not running with JUnit 4. Unreturned. Well, it says it's a null pointer at line 33. So there's only two places where that null pointer exception could occur. It could either occur here, or it could occur at this then return. Huh. JUnit 5 Mockito when null pointer exception. That's the same one. Another bug here. This dot addition service is equal to the mock. This for the multiplication service is that. And that is equal to that. All right, that is working successfully there. Now, let's continue. So, what's funny to note here is we're capturing any int here and any int here. So when we do this multiply, like this could have been some random number like this, and this program, it just has to be the size of an integer. Still too large. Wow. All right. So if I run this here, it will still run, right? Because we're capturing any ints. Everything still works as expected, because our multiplication service that we pass in here is a mock that it doesn't actually really multiply. It's basically saying, like, if you have any two integers that you pass into this function, I'm just gonna return 150, and then same for the subtraction service, right? So we don't actually need to care about what's in here. And so let's keep this in mind, because we're gonna refactor this test later in a way where it makes sense what test we're writing. So not only are we gonna be fixing previous tests and make them more clean and consistent, we can create tests in a way where it's like, I'm creating these tests and they have a specified purpose, and I can maximize the value for each test I make. Every test will provide a significant amount of value, instead of having a test suite which may have, it may have like hundreds of tests, but some tests are extremely valuable and the other tests are repeats. we're gonna avoid that scenario. We're gonna create tests in a way where every test provides an impact and a value. So let me run this one more time. And then this, we could be like, let's just say it's a simple addition output. And we'll say that this is just a sample multiplication output. And then like we didn't really care what happens here. So we could be like, and I'll toss our samples, like we'll toss them at the top. Be like, our sample addition output is equal to 0. And these are only samples, so we don't really care what their values are. We just specify them to whatever value that we deem fit. And let me adjust these to be private because we're not using these outside these tests. And let's make these static. Maybe we're not changing them, and we don't really care about what they are. So we'll make them final too. Why not? You can be like sample addition output. And then we can be like sample multiplication output. And let's end there. But we can actually not. Let's not do that. Let's make a sample subtraction output. Oops, I messed that up. Apologies. And then here we can just copy and paste. All right. Let us run this single test to make sure it works. All right, and that works. Let's run all our tests again. And so we're like, all right, this is still 0 here, and then this is still 0 here. It's because we never mocked those out. Let me add these to this right there, and then we'll add this right there. We'll run everything again. It still fails, but this time instead of 0, it's gonna be like, hey, it's actually 140. What's going on here? And so we're just gonna be like, we'll change this to whatever we wanted it to be. So I've been hard coding these variables, right? But in actuality, these all kind of just match the expected value. And so we look at this, and then we run it. we see everything run successfully. So let me commit this out real quick, and then let me explain some things that might be eye-opening to even more experienced unit testers. So I will say something like, let me get those inversion files here so we can be like plus add diagram. But then we can also be like mock outs methods in calculator tests. We'll commit and push that out here. So I'm going to start off with some insight, and then we'll code a little bit more, and then we'll follow up with another insight. So first insight is unit tests are really this something that I would consider like a glass box test. I think the official terminology is white box testing, but you know, couple words, they a little bit synonymous in this case. But in a glass box testing fashion, right, like we're declaring our units, so we get additional value when we confirm that our units are working as intended. We specify, it's like, hey, this we're setting up this add for addition service. So we get additional value if we can be like, when I did calculate y, did I actually run this addition service that I mocked out, or am I just faking it? Is this not actually being run whatsoever? So what we can do to address something like that is we can add verifies. So we can it might be considered part of the then. Asserting what you want to be true is true, but I'll add a little one here, even though it's not. I haven't seen it too much where people put a comment that's like verify, but we'll add it here. So we can be like verify that, hey, you know this addition service with the any ints. Make sure that you actually called it and that you only called it one time. This might be useful if you have something that's like, we'll go back to the black and white picture example, right? Let's say you know your code only really wants to turn the picture black and white once. You can be like, hey, make sure this only calls once. Make sure it doesn't call 0 times, or that it calls 20 times, the waste of CPU cycles or something like that. We have advantage in unit tests because our tests are our code. The addition service and the addition service test, or in this case, calculator in our calculator test. Those together is what makes that unit a production-worthy unit of code. Our unit tests aren't just simply something that we create or use afterwards. We work with our test and our like the class itself together to create the code. They aren't in isolation. So let's take advantage of the fact that they're not in isolation. Let's make sure our code works as expected. So we add that. We import that. Let me make sure I'm importing the right stuff. Let me not rush it. Mockito times and Mockito verify. And that. we track our multiplication service. And then we also do our subtraction service. And then we run it. And it should still all work successfully. Now I'm going to break this just as showing off what happens if these verifies were not correct. It'll be like you wanted this to happen, but it actually executed only one time. So we see the value immediately, right? We confirm that the units that we're using in our code are only being used in the way we want them to be used by. So that is a very powerful tool, and it may not seem obvious, and there might be some controversy. You'd be like, I'm gonna go for more of like a black box testing approach, where a black box is the opposite of a glass box or a white box, where it's like, I don't care how the units are being used, just make sure the output that I get matches the result of our input. I would like to push against the notion of black box testing for unit tests. There's a lot of value that you're missing out when you don't do a glass box approach. If you're mocking anyways, then you might as well do the verify because you get that additional value. And I believe as you work more and more and use verifies. Go break out of that comfort zone of just relying on the black box testing. I will assure you will get more value out of your code and your tests, which are both part of one. They're both part of the product that you make to get successful, right? Like it's not the code by itself, it's not the test by itself. It's those things together what really makes it all work nice and smoothly. All right. So I'm going to do the same thing in every one of these. I want the verify out here. Verify out here. And then we run that. All right, everything's working as expected. When we commit this code, and then I will drop a bombshell, another thing that might be surprising for both somebody new working with unit tests and the more experienced ones. I forgot all the changes I made here, so I'll expand that out. The only thing I did was add verify, so all right. What happens? What happens when I run this with code coverage? We will see that the numbers have changed. It's what we expect it to now. Our calculator is only testing calculator stuff. Addition service is no longer being covered by code. Multiplication and subtraction is no longer being covered by code. What happened? We turned our integration test into a unit test. But something strange we see now. We look at our our tests, right? And they seem almost the same, really. Like our expected is the same. The expected is not the same. The expected is different between all of these tests, right? But almost all the whens are the exact same code. All the verifies are the same code. All the asserts is the same code. The calculate is the same code. So this is telling you something. This is telling you that you just made duplicate tests, right? You like this test is basically the same as this test is basically the same as that test. So what it's telling me is we can get the same amount of code coverage. We can get the same amount of confidence with with 1/3 of the code. We don't need all of these tests. In fact, we made them like this initially because when we were initially made the tests, they were integration tests. But now that you've learned more, and that you've gone past the point of starting with integration tests, you can now start with unit tests, right? You don't have to follow it like what we did from this video beginning to end. You can start in the middle where we created our mock services and our sample inputs and outputs, and those can be used instead for what we expected stuff to be. So, for example, right, it's gonna be scary, right? We committed the code, so it's gonna be fine. I'm gonna delete these other tests, and then we can see what value we're actually getting from this unit test, right? So given what input, well, the only things we really changed were the input and the expected, right? So the value that we're given from this test is kind of like, all right, we're given really any input. When the calculator calculates, then we just expect the corresponding output for that input. So it's like we could have tested those other things in that scenario, but we really didn't need to for this case. We could have passed any input here and we would have gotten what we were supposed to be expecting, right? Like this could have be like whatever here, right? And we could run this. As long as our expected matches what we ever expected to, like this could have been whatever, right? It takes additional insight to know that in our calculator, we're not testing addition service. We're not testing multiplication service. We're not testing subtraction. Those are just concepts hidden behind the interface of those services. All calculator really cares about is like, did I call this addition service and did I get something back? Did I call multiplication service and did get something back? And I call subtraction service, did I get something back? It's the notion that calculators is really like a facade. It's the purpose of calculator in our case, and if we open up the code, it makes more sense. It's not doing any logic itself right here, right now. Really, it's really just a pass through these services to get value, and that's how we can take advantage of that. We're not testing addition in our calculator. We're not testing multiplication in our calculator. We're not testing subtraction in our calculator. We're testing our calculator if it's a calculator. So we could be like, given an input, when calculator calculates, then we expect an output. That's all we really care about here. And we can even do like math.random here, but I'm not gonna waste the compute cycles here. We can just set this back to 140 and 110. It doesn't really matter in this case. And there we go. We reduced our unit tests by we reduced it to a third of what it originally was. And let me commit this out first. Call them duplicate, really. And remember, this might be like, I don't understand why you did this, right? But just keep in mind that we turned our test from integration to unit, and that's if you understand that portion, then you will truly understand the value of what we just did there. And I deleted that because it's just, I don't think we need to keep that there anymore. So code cleanup code. Let's see, running out of water, but I have some more things I want to talk about. We'll start with a new condition. Let's say let's start with the multiplication service. Multiplication service. Let's say it may error out. Let's say let me give a real life example, right? Let's say you have a service that calls another service, but maybe the hardware behind it is not good. Maybe you have a service running on a legacy system where it's like, for whatever reason, the network doesn't connect at around like 5 o'clock in the morning or something like that. Whatever the case may be, you can't always assume something works or something like that. And in this case, and we're doing it in a safe scenario, and our multiplication service will always work in our case, right? For any type of integer. But let's go into the more hypothetical situations. Something that an interviewer may throw out at you, being like, this isn't always guaranteed to work. Let's create some software to make sure that our calculator can handle when the multiplication service errors out. So in our test, we'll start here, and I'll add a comment here. Be like, assume this may throw a runtime exception. I'm only adding this comment here for people that may be looking at the code and be like, what is going on? Assumes this may throw a runtime exception. Use used as a hypothetical example. So given that that may throw an exception, right? What do we want to test here in our calculator? So our test could be like public void given an input when multiplication service throws an exception, then calculator throws, or kind of like bubbles that exception up. So advantage, right? You did integration tests with real services, right? Some of those times you can't force a network to be down. You can't force a network to be down at 5 o'clock in the morning at a Tuesday night on a day behind the full moon. With unit tests, you don't have to run the tests and wait for that perfect error scenario. You can force the error to happen. So we'll start with our. I'm gonna copy and paste this just to have the boilerplate for it, but I'm gonna be deleting a lot of stuff. We'll get rid of these verifies for now. We're still calling our calculate. Our assert is gonna change, so I will take that out. Our expected is the same, our x is the same, our addition is the same, but different thing happens here. What did I want to happen here? What I wanted to happen was a little bit something more like than throw. New runtime exception. An exception. And we don't have an expected anymore. That should just run in all that jazz. First things first. I don't like this hard-coded variable. I'll make a sample exception message. We'll call this sample exception message. All right, let's run our stuff, see what happens. All right, it threw an exception. Our test failed, but if we think about this, right, our test should pass. Like, we want this exception to be thrown, right? We want to make sure that the stuff works as we expect it to work. So what we do is to test the scenario where an exception occurs, we kind of do two things at once. We do a try. We try this out, right? We don't really care about the value here. If it works successfully, it will go to the next line. So we should be like, you shouldn't have worked successfully. It should have failed. Because if it gets to line 60, then line 59 would have completed. And we don't want 59 to complete successfully. We want it to fail. So we'll catch any exception here. And to make sure that the exception is the exception that we wanted it to be, then we can assert equals that the expected message, which is our sample expected message, exception message, is equal to e.getMessage. And the test should pass now because we're now expecting that behavior. And that failed, obviously, because they don't match, and they don't match because I didn't update this to match. But now that they do match, they will be equal. Now the power of the unit. The power of the dependencies, the mocks that we inject, right? When we verify, let's copy and paste, see what happens. Wanted but not invoked. Subtraction never happens. Multiplication aired out. And subtraction never got executed. So let's take advantage of that. We could be like verify no, or be like, go up here, verify. You can do no more interactions or zero interactions. Pretty similar in this case. In our case, subtraction service never got executed. We could verify to make sure behavior works as expected in our units. Copy and paste that out. Move that over here to accurately represent. And you don't need these comments when you're writing tests in your own production software. I'm just doing this for the purposes of this video tutorial, freestyle tutorial thing. Now we got two tests that provide value. We have the one where everything works happy. It's a happy path. It goes all the way down. Everything works as expected. We also have one that's like, all right, multiplication aired out. What do we do now? Let me commit this out because it's all working and running. Add multiplication or test when multiplication throws a runtime exception. And you don't have to assume that all your services throws exceptions, right? It's only, in this case, we knew that we created a hypothetical situation where multiplication service could error out at 5 a.m. in the morning on a full moon, right? That didn't have to happen. But we can write tests in a way that asserts it. And I would suggest that you would only write a test like this when you know something throws an exception like that. Let's write something new now. And before even that happens, I am going to take out this sample subtraction output for now because we never used it. May come back in later, but who knows? So we'll do another code cleanup here. New condition, new condition, new condition. New condition, number 2. What do I want to do? I didn't come up with too much stuff here, but let's do a one negative situation. So our condition is when x is negative, don't do the above formula. Oops. Do the following formula instead. And this formula will be as simple as 5 minus x. Not too hard to do. But it might stump some people, and this is interesting, right? So what we want to do is you can start from either approach, and I would encourage you test out both, see what works best for you and your team, right? You see a lot of people that are like test-driven development is always the way. And let me explain test-driven development a little bit, because there's some confusion here. Test-driven development is not the same as unit testing. All test-driven development, the essence of it, what it really means is you must create your tests before you create the code that fixes those tests. And I'm neither for nor against it. You can try both. Try both. See what works best for you. I would recommend a different approach. And I call this one the quality agile software approach, right? Which is do the thing that creates the production software in a timely fashion. Make it agile, make it flexible, but make it good. Make good software, right? So in essence, right, it's like you could follow a strict TDD approach, but maybe not doing a TDD will get you the same results in the end. Or maybe it won't. And in that case, you probably should have used TDD, right? So it's leveraging experience and knowledge of trying out both. See what works for you, and then when you solve new problems, leverage that previous experience to create the software that you need in the best way that you know how to make it. So I'm going to just start with the test for now, though. well, because we did it the other way, I want to show it this way just from an experience perspective. First things first. Let me grab one of these tests. I'm gonna copy this stuff in. And now we're like, all right, what do we do now? We're given a negative input. So given a negative input, when calculator calculates, then we expect the negative equation results. All right. -5. -5 times 5 is -25. We expect it to be -25. When we calculate this, we expect that to be there. We actually wanted no. So let me run this through. Yeah, let me change this. verifyZeroInteractions to our addition service. verifyZeroInteractions with our subtraction service. But we did want one with our multiplication one, so we'll keep that in there. Let's run this through and see what happens, shall we? Hey, look, what happened? Well, we expected -25, but it was actually 0. What happened here? What happened here is we didn't make the code to implement this functionality, right? So it just goes through the normal workflow of doing that 5 plus x times x minus x as shown in this top equation, right? We didn't implement this new equation down here. And I messed up. That should be subtraction. So let's fix this up slightly. This should be 10, if I'm not mistaken. And we verified the subtraction service. So we'll change this into multiplication. We'll change this one into subtraction. And we subtract. All right, let's run this through, see what happens. All right, and this is what we expected, right? The only reason why the assert passed here is because we're using those primitive values. And this, another reason why you want the verifies here, right? We take out these verifies. Test passes, but that we didn't want this to pass. We didn't actually fix the code yet, right? So it's like gives you more insight to see if the code works as expected and that you're not writing a faulty test. So we get to this part and we're like, all right, these verifies didn't work. Our test is not passing, obviously, because we did not write the new functionality. We write the new functionality here, where it's like, if x is less than 0, then we can just return subtraction service subtracts 5 from x. We can actually move this down over here. Because this is like 5 minus y equals 5 minus x. And speaking of the formula, I probably should have put in y equals 5 minus x here, just for clarity's sake. All right. Let's run our test suite again. And that works, right? And so that's 100%. Let's imagine we didn't have this test here, right? Let's control / that / that, run the test with code coverage. And the test still passed, right? But your line coverage went down from 100% to 91%. And it went down from 191 because line 19 here in this case was never tested when that code is commented out. You go back to here, you uncomment this entire thing, and then you run the test again with coverage just to show what happens. You'll see this number go from 91% to, if we replace the active test suites, back to 100%. So we're adding new tests, right? New functionality to our code. We're confident that it works the way we expected it to. And then we see, right? We see that we can start off with our test. We can take a test-driven approach and make the test for our code. So either way works, right? Just choose the one that is best. Choose the one that will get you there the fastest with the same results, right? Start with the code and write the test and go with the code. You got to understand that it's all combined together. So either way, you're going to get into either way, if you make progress on one front or progress on the other front, you are going to make progress overall. So let's keep that in mind. Commit this out. Not comment this out, commit this out. Make sure we commit that code. New functionality for negative numbers. All right. This is the part where I want to get into some advanced unit test tactics. Let me summarize what we have so far so we can go into these more advanced topics. So we created an application that uses a calculator. We have several restrictions for this calculator and several pieces of functionality that we need from this calculator. Basically, our service returns an output y given an input x using this formula. We have a restriction that calculator cannot use these operations directly, so we must use other classes. In our case, it's the addition class, the subtraction class, and the multiplication class. Multiplication service may error out, which mimics scenarios in the real world where a service isn't guaranteed to run 100% of the time. And then we got a new condition here, which is just another part of the workflow for that, for this calculator. Now, if you're just jumping into this portion of the video, this is kind of the material that you want to know, kind of the new innovations within unit testing. So I was working with a coworker where I work, and we implemented some new functionality into our code, It was like a single line change, but it was inserted kind of like in the middle of the flow of the application. What happened was kind of eye dropping. It caused us to be kind of flabbergasted, to be honest, where changing a single line of code, it affected every single one of our unit tests. They were brittle is an understatement of a word. Like, we had to go back and change every single unit test. So that got me thinking, right? And we kind of talked this out as a team, but we were working this out. We made some diagrams, right? And we drew out some stuff. And I think we found something new and innovative that will make unit testing easier, not only for beginner unit testers and beginner programmers, but for the more experienced, right? And I would like to make an analogy here, in that unit testing sometimes can be constructed in a way where it's like let's say you're making like a recipe, and the recipe takes a long time, and there's a bunch of different ingredients, right? And we can compare like mocking and verifying as those multiples of ingredients, right? Well, you can add a little bit of too much ingredients. Maybe you misread a step in the recipe, and you did something wrong, like when you're cooking something, right? And it's like that one portion that you messed up in that step can cascade down to the final dish at the end and completely change the flavor profile of that recipe. Another analogy is if you're into like Brazilian Jiu-Jitsu, right? And you're trying to go for that submission, but you're going for a really complicated submission, right? You're not going for like a triangle, but you're going for like just something like super out there that you may have saw in like a YouTube video or something that takes like 20 steps, right? And it's like you mess up at like step 12 or something like that, or just some crazy thing. I'm not sure if a submission out there exists, but that is like a 20-step process. But if you imagine if there was, and you messed up one part, and you mess up, and then your opponent gets right past you, right? And then it's like you just lost the entire game right there. You did not get the submission. So we've created a way, and kind of like a way of creating tests where you go for, instead of going for like that super long submission, if we're taking the Brazilian Jiu-Jitsu example, or the super complicated and long recipe, right? It's combine a ton of smaller things together, right? In Brazilian Jiu-Jitsu, this would be kind of like a submission combo, or like a submission chain, where you may rotate from like a triangle to like an arm bar, and then transition from there into something else, right? Like maybe you can take the opponent's back in the rear naked choke. You just go cycling between smaller stuff themselves that are individual submissions, right? Instead of trying one completely big complicated one, you try a lot of individual smaller ones. But then there's also the recipe example, right? In this case, in this scenario, it might not be too analogous, but like getting pre-made ingredients, right? It's like maybe your recipe is a spaghetti meatball recipe, and it takes like 100 steps to make the sauce. Again, may not be the most realistic example, but it's an example nonetheless. You got like it takes 100 steps to make the sauce. To make the noodles from scratch, it takes like 50 steps, and then to make the meatballs, it takes another like 40 steps. Right? You got 190 step recipe that it's gonna take a lot of time. You're probably gonna mess up something, right? Or you could just go to the store, buy spaghetti, buy some sauce, and then buy some meatballs. Cook them individually, put them together. You got yourself some spaghetti and meatballs. But that is where we're going to take this to the next level. So the new innovation right here is, and to summarize to people that jump to this video, we have 3 tests here. We have an input, and this is kind of like the happy path, right? This is what we want to base off our other tests on. And you'll see that clearly in the follow-up examples. Then we have one where it's kind of like the path changes in the middle of the test. And then we got one here, which is like a path changes in the beginning of the code. So, under first steps first, your tests know what your code understands what units is using. So take advantage of it. Take advantage that you know what units you're using, the order those units are, and how they're being used, because you can use that to create code and unit tests in a way where when we created, for example, when we solved our problem for work and when we were working together on that piece of code, when I say working together, I mean me and my coworker and I, we were able to change it from needing to change every single unit test to only needing to create the test that we need to create for that new piece of functionality, which was absolutely fantastic. Could not believe the drastic difference from it. Hours and hours and hours of work saved based on this new methodology of creating tests. So we need to create 2 interfaces here. We want something that's a private void mockUpUntil method. And then we want one more void, which is a verifyUpUntil and then we have one optional one, which is a verifyUpUntil used only when the method is a void and the test being done is the verify to underlying services. So there's a very niche case where you want a verifyUpUntil by itself, but the verifyUpUntilAnd will cover most of the functionality that you want. And when we continue on with this, because it's a lot easier to see when you see it all go down in fruition and all that stuff. So let me make sure I'm spelling until right. Until is 1L, so make sure you have that spelled right. All right, our tests and our code, they're all packaged, right? So what happens here? We use our subtraction service first, then we use nope, that's in the side flow. We use our addition service, multiplication service, and subtraction service. So take advantage of that. We'd be like, and this is why you need a happy path. You need a path that goes from you want a test that has the path that starts from the top of the test and gets to the, not the top of the test. Let me take a second here. You want something. You want your code that you are testing start at line whatever the top of the method is that you want to test, and go all the way to the bottom at the same level. So whatever test that you're using needs to hit a code execution flow that gets to the bottom right here in this case. And this method should work for anything. So there's no restrictions there. If you understand how the method works, then it will work. And not only that, it will adjust. It will adjust your code. This is when we're saying the test can improve the code base. This way of writing tests will create a scenario where you make better code in the end. So you'll see these results if you write your tests in this sort of fashion. So we started with the addition service. So, and best way to do this would just be start with this happy path. mockUpUntil. So where do we want to end with our happy path? We want to end at the end. We want to mock everything, all right? So we'll say we're mocking everything. And then we want to verify, right? So we verify up until and we want to verify everything in this situation, right? So how do we choose which? We need some sort of way of breaking where our mocks up are and where our verifies up are, right? So I think the best situation where we found and worked best for our case was in an enumerator. So we can create something like a mockID. And it could have all, it's one of them. It could have addition service, right? And it could have multiplication service. And we do all that stuff. And then we can be like, mock all from mockID. Same thing over here. And we do want to get it for all of them. So how does this actually work, right? Like how does this help? Which is the crux of the question, right? These are the new advancements you want to see. So what we do, take out all our when statements from our happy path. In this case, we need some sort of sample subtraction output. If you've been here in the beginning of this video, we took it out, but this is the time where we want to bring this back in. We'll change that into subtraction output. Change that to that. I'm gonna change these into like 1, 2, and 3, just in case there's ints have some weird behaviors. So we'll change those. We're missing one. Subtraction service is 1 here too. And we change this to be sample subtraction output. Now, in our verifies, we do something similar. Copy and paste that out. Boom, we do that. So we need to stop at the right place, right? If our mockID is equal to the addition service one. then we just want to end the execution flow. This is a guard statement preventing us from continuing on if it hits that point. Go here. We do subtraction service. Actually, multiplication service. This is my bad. Copy and paste that out. And subtraction service. And then the same thing goes down here. Verify up until and is the opposite way of execution flow. So you insert them at the bottom of your verifies. If you're doing a verify up until, you would do them at the top, same as you did your mocks. But you only need to do verify up until in certain scenarios. Let's do that. Do that. And do that as well. And so we go up here and we see that we only have this code left, which is fantastic. This is fantastic test. It looks clean. I mean, you're mocking everything. You run the code, you assert it, and you make sure everything works as expected. And that didn't work because this should be sample output message or sample subtraction output. Which makes sense because we know how that code works. It's right at the end. It's the subtraction that matters. But this gives you advantages of not needing to adjust multiple places where you know the happy path exists, right? You only care about, in this case, where something different from the regular happy path occurs. So in this sample, right, we are testing something specific to the multiplication service. So we want to mock up until the multiplication service. Throw that exception in the multiplication mock. And then we want to verify up until and the multiplication service. And then we verify the new unexpected, the different behavior than what is normally commonly found in the happy path. So it will save you some code. It'll save you some mental overhead. And your tests will look a lot cleaner as a result. So we do mock up until. And we know. We don't even have to really think about it. It just comes intuitively. So we do mockID multiplication service. And it comes intuitively that we do verify up until and our multiplication service here. And we've done some research, and we haven't seen that this method of testing has ever been done before. So this is a relatively new methodology. Not even relatively new. This is just some fantastic way of doing testing that really hasn't been done, or at least I've seen been done in the past. So run all our tests. And then here, this is a little bit different because we know that the execution flow changes based off of the input. So what we do here is different. In this case, this happens before any of the services that we really cared about in this scenario. So this would be a mockUpUntil. Yeah, no. We don't do anything here. And the reason why we don't is because this is a completely different flow. It's almost like it's a different method. So it's an indicator that this functionality, instead of having an if statement at the beginning, maybe put it out into a different method. Be like, hey, here's equation 1, here's equation 2 as two separate components, right? So right now we have a calculator, one method, two flows. But this easily could have been two method, one flow each. So that's something to consider. I won't waste time doing that adjustment now, but because there's another topic I want to cover, and then I'll call it a quit for this video. So now that we've seen the benefits of doing the mockUpUntil and the verifyUpUntilAnd, and you'll see these benefits a lot more if you're working with a class that has, you know, maybe like 20 unit tests instead of 3 unit tests, and which I consider 3 unit tests to be the minimum barrier of entry before this becomes useful, right? So if you have more than 3 unit tests for a method, then, or less than 3 if you have less than 3 unit tests, then you don't necessarily need to implement it like this. But I would, if you have more than 3 unit tests for a method, I would just go ahead and start making your mockUpUntil and your verifyUpUntilAnd, because you'll see benefits of it immediately. So 2 more things I want to cover in this advanced portion of this tutorial is I want to cover the scenario where you use a mock, or when you use a service after you use another service, So it's like, for example, let's say this equation changes. So let's have a requirements change. Let's say the flow should be and we'll say the regular flow. Let's say we want to multiply it by 2 at the end. So let me add some parentheses just to make this clear. And then one more right here. So we had this subtraction at the end, but now we want to multiply again. We could start in our test, but let's start changing the code just because we have it. Gonna commit out any changes that I've made just to make sure that we start from a place of security and safety. mockUpUntil. So let's say this is a demonstrate. So let's say intuitively you want to add this new piece of functionality, which looks like that. We'll change these to lowercase to keep them consistent. So intuitively you want to do something like this, right? And it's like, all right, I'm just going to do multiplication service dot multiply by 2 of our y. And we can implement this in our multiplication service. It'd be like that. Times 2. And so let's go back into our test and see what happens, right? And then we expect an output, and it's 0, right? Because we never updated our when statements. So instead of needing to multiply or change this when in multiple places, we can just go up into here. And if we had more tests, we would have seen a couple more errors here. But functionality is not too advanced in this service, so we're given the nicety that only one test failed. But I can assure you that multiple tests would fail if we were working in a more complex project. So we can do like multiplication service multiply by 2 of any int. Just any sample multiplication output will do here. And, freedom again. We get the freedom of only having to adjust the mocks in one place instead of having to change the happy path for every single test that does the happy path at that certain point. So a lot of benefits there. Messed up somehow still. Let's see. Given an input when it calculates, and we expect an output. What did I mess up here? Just need to think for a second. Assertion failed. Happy path now is the sample multiplication output. We run that. Run our entire test suite. All right, here is where the fun part begins. So it feels weird, right? It's like you add, you multiply, you subtract, and then you start reusing this multiplication service, right? Which intuitively it feels weird because the way that you created your tests, you assume that they're used in a sequential order, so it gives you a little bit of uneasiness that it's like, wait a second, I made these mockUpUntil and those verifyUpUntil, and assuming that they're in some sort of a sequential order, but I do my multiply, then I do my subtract, and then I do my multiply by 2. This feels weird. It reflects weirdly, right? And we can see this here, right? It's like, where does this verify go now, right? Because I want to throw a verify like at the end here. It doesn't really make sense, like what's going on. And you will see this. It might not show up because of the code doesn't. The codes is simplistic enough where the complexities don't show, where usually you would see an error pop up. Maybe there's some different code execution in Subtract, right? Let's say there's like some imaginary scenario where it's like Subtract doesn't execute that other multiply, the below multiply. Because it is 3 p.m. on a Tuesday or something, right? How would you deal with this scenario? You can't do the mockUpUntil because and the verifyUpUntil because there's an assumption that they're used in sequential order. What it's telling you, actually, what your test is actually telling you to do, like it forces you to work in a better way using this new methodology. You need to create a facade that uses that subtract and that multiply by 2 in a way where it's like, and you can call it like subtraction and multiplication service. Let's be a little fancy with this name. You don't have to name it like this. Call it like subtraction. Is that a word? It's a real word. I won't use that word. We can use something like the sub multi service. And we could be like subtract, then multiply by 2 y of x. And thereby, we reduce the complexity of this. We can create inject this new facade as a new class, and we can achieve additional benefits. This is sub multi-service. Let's create that class. Here we go. Let's implement this quickly because I'm getting tired and this video has been going on for a really long time. Get that out. Int x, int y. Let's get the constructor in here. Multiplication service. Cancel that. This dot subtraction. Let's declare it. Let's get that in there. And then we can use the subtract dot subtract. And then multiplication service. So we could be like output is equal to that. And then we return our output times 2. And there's additional stuff that you can do here, right? Now that we have the subtraction service and the multiplication service here, you don't have to do it, but you can just facade. You can just pass through the multiply method and the subtraction method in your calculator. Your calculator really doesn't need the addition service, the multiplication service, and the subtraction service. We have that new sub-multi service. So all it really needs is that addition service and that sub-multi service. So we can do that refactoring later. I might do that in my free time and commit that out in a branch or in master just to show you all how that works. But I just want to throw that out there so you know ahead of time that you could do it if you want. And I'm not going to do it right now because again, it's getting a little bit late and I want to finish this up. Equals sub-multi-service. And so we do that. We do that. Hold up. Took out too much stuff. Here we go. And fantastic, beautiful. We've refactored. We've made this so much better. We don't even need subtraction service anymore. We can take this out immediately because we know we didn't need it. Only using the dependencies we need, we achieve a better functionality of our services. Change that. Multiply. Subtraction service was needed here still. Control Z out of this. I forgot about that second workflow, my bad. We'll keep it here for now, but if we didn't have the second workflow, we could have taken that out. But you can also remember, as I said before, use subtraction and multiplication directly in the solve multi-service, and you could actually take out subtraction and multiplication service here if the number of dependencies that you need for this class gets too big. So it just gives you more options in a sense. All right. Now in here, we run our test. And we still have compile errors because we need our sub multi-service now. And that takes a new of a subtraction. If you're using Spring Boot, this would be auto-wired. But we're using vanilla Java as a demonstration of dependency injection here. We'll do that. This should not run because we need to do the same thing here as well. We need a sub multi-service here. a sub multi-service there. Run the test. It's not gonna work. We haven't mocked it out. We haven't verified. We didn't change anything. All that. Oops. No. Oh no. Everything's broken. We only need to change the mockUpUntil and the verifyUpUntil, and it'll all work. I think that'll automatically create. Let me just check up there. Yep. Sub sample sub multi output we want here. And again, this might seem like a little bit of work, but the amount of work that you would have if you didn't have this would be a lot more. So we get a lot of benefit from this. Just want this one. All right, and this is not going to execute because I didn't change the happy path of the calculator. Yep, that is to be expected. Because the happy path here goes from, we take that out completely. So it goes addition, then multiplication, then sample multi-output. So this is no longer this. This is sub multi-output. We run all our tests again. Still wrong, but in a different place. verifyUpUntil is wrong. This is never executed at all, actually. So we could be like verifyNoMoreInteractions with the subtraction service in this case, or zero interactions. And then that is that. We run our tests. I know it's gonna work. Nope, it did not work. We messed up something again. Oh, and this is sub multi-service. This is not the right method. Only one place you need to change, not multiple places. If we didn't have this, maybe scenario, maybe you have to update 10 tests. We do have it, only update in one place. All right, all that works. Let me commit this out. So what value did we see here? Not only did our make it easier to write all these tests, but we learned based off of the way that we're writing the test with the mockUpUntil and the verifyUpUntilAnd that the structure of the actual code could have been better. We didn't need to do a subtract then a multiply again. What we really needed was a service that would do it for us behind the scenes. And so, one more time to explain this. Some multi-service could just pass through subtraction and multiplication if this constructor gets too long. It is up to your preference whether you just solely use the sub multi-service or if you use all the different beans in conjunction to get the functionality you need. One last thing that we need to cover before I finish this video, and it's been a long journey, so I'm glad if you've stuck through and watched this entire thing. Let's just say we same value of x, and all this does is return x. We want code coverage for this, but we don't want it to impact the same stuff that we've done for all of the other testing. So if we replace the active test suites, we notice the amount of test coverage we have is so much more smaller. And obviously this is a one-liner, you wouldn't test it in a real life scenario, but imagine if there was a bunch of code in the same value method and we actually wanted to test it out. How do you support mockUpUntil and verifyUpUntilAnd if you have two different methods with two different flows, right? I mean, it's all really like it's like completely different code. What's up? It's completely different services, different mocks could be used up in this scenario, and different verifies can be used in this scenario. So how do we format these tests in a way where we can test them out with mockUpUntil and verifyUpUntilAnd with two methods that we want to test in a class, and not a single method that we want to test in a class? And to that I say, and it's a little bit unfortunate, but it makes sense if we think about it, and how it's formatted, really. They're two different execution flows. They're two different methods. So we need to make an inner class solely for the first method and one solely for the second method. So we could have a class that solely tests the I don't even remember what the name of the method is. Calculate y. And we nest every single thing in this test. It needs to be a static class. And so you notice, notice if I run that, it's good. We can create an additional class that tests the other method, which is same value. And all we really need to do is, our setup is going to be the same because it's all the same class, right? Let's extract that out. I think this should not be static, now that I think about it. what is going on here? So we want our calculate y class to test, and we want our same value to test. So this is an @test, and all this one really is we can do something as simple as this, just because I'm super tired and it's time that we finish this up, this video. All right, let's see how we do this again. Test inner classes JUnit. Oh, yep, it's this annotation. So this needs to be a public static class. It might just need to extend suite. Hold up. JUnit 5. This is what it gets you. All right. Take static out of these again. Take class out of those again. Add nested. There we go. That makes so much more sense. All right. And then finally, right? And this is what you wanted to see at the end. So we have our calculator test. Calculate y. Where is the other one? Same value. This is a public void. This is my bad. All right. Pay close attention to this number at the right, 66 and 92%. We run it with coverage. We can reuse the mocks and the setups for the method, but all we need to do is make nested classes for the methods that we want to test, and then we can be like, hey, calculate y looks like that, and then same value looks like this, and we are golden. If you stuck for this long to watch the video, I'm glad you took the time to learn more about unit testing, whether you're a beginner or somebody that's looking for some of the new advanced tactics that we have discovered in the unit testing field. But other than that, thank you so much for watching. This is Andy Nguyen, and thank you.